Okay, so the first thing that we need to do is we need to identify what the angle relationships are for each of these. So if we're taking a look at angle A and relating it to an angle that's we know that we can compare it with. So we only know the value of 125. So how do angle A and angle 125 relate to each other? What relationship do they have, David? Supplementary. So they are both supplementary angles. So angle A and 125 degrees are going to be supplementary. So that means that we can set up an equation to solve by doing angle A plus 125 is equal to 180 degrees. And then we can go ahead and solve by doing the inverse operation, which is to subtract 125 from both sides. So you should have gotten that angle A is equal to 55 degrees. Okay, what about angle B? How does angle B relate to 125 degrees? What's the relationship there? Richard? They're vertical angles. So angle B and 125 degrees are vertical, which means that they are equal. So that means angle B is going to equal 125 degrees. Plain and simple. Okay, and then what about angle C? Angle C doesn't have a relationship to 125, but it does have a relationship with the 60. What is the relationship that angle C and 60 degrees has? Jeffrey? Complementary. So angle C and 60 degrees are complementary angles. So that means that when we combine them together, they're going to equal they're going to equal 90 degrees. So angle C plus 60 is equal to 90 degrees. And again, we can just do the inverse operation of subtraction. And we get that angle C is going to be equal to 30 degrees. Okay? All right, if we take a look at problem number 2, what is the parallel cross-section of a trapezoidal prism? I want the parallel cross-section of a trapezoidal prism. I don't even have to draw it. I just have to remember my rule. My rule for parallel cross-sections, no matter what the shape is, a parallel cross-section is always going to be what? Huh? If we're doing a parallel cross-section, it's always going to be what on the shape? Hassan? The base. If we do a parallel cross-section, it is always going to be the base. It's always going to be the base of the shape. Let me show you again why. So I'll draw a quick trapezoidal prism. So if we have a trapezoid, so here's my trapezoid. Here's a similar trapezoid to it. And then I'm just going to connect each of the vertices to each other. There's my trapezoidal prism. And then I'm going to do a parallel cut to the trapezoidal prism, which means I'm going to cut it so that I do not touch the base at all. A parallel cut so that I do not touch the base at all. And I pull that apart, then what I'm going to see are the base shapes, which happens to be a what? A trapezoid. If it's a trapezoidal prism, it's going to be a trapezoid. Remember, if it's a perpendicular cut on a prism, it's always going to be a rectangle. If it's a perpendicular cut on a pyramid, it's always going to be a triangle. Okay? All right, and then what is the cross-section you get no matter how you slice a sphere? What are we always going to get, guys? Circles. No matter what. No matter how you cut a sphere, you will always get a circle. A lot of people think it's because it's made up of an infinite amount of circles, but it's actually not. A sphere is actually made up of an infinite amount of pyramids. So, it's made up of an infinite amount of pyramids, or triangles that are connecting together into the center of the sphere coming out, and they form a spherical shape. So, All right, let's take a look at problem number 4. Problem number 4, we have this line with two triangles that are proportional to each other. Okay, they are scaled drawings of each other, and we want to know which of the following statements are true. There could be more than one that's true, but we want to make sure that we're checking all of them. This happened to be on a recent test, and I just want to go over it because it was one of the most commonly missed questions, not on your test, but on our standard test, and it was one of the most commonly missed questions. So I want to make sure that we go over this concept because it is an abstract concept to see. So you want to check every single one of the statements to see if it's true or not. It says the slope of line segment AC is equal to the slope of line segment FD. So when we're taking a look at line segment AC, I'm going to go ahead and highlight that in pink. So from point A to point C, that's located right here. And then they're saying that it's going to be equal to the slope of FD. So I'm going to go ahead and do FD in green. So here's where F is, and here's where D is. Are those equal slopes? Yes or no? No. Why not? What type of slope is AC? What type? Like positive, negative, zero, undefined. What type? Positive. It's a positive slope, right? It's increasing. What type of slope is the green line? Zero. So they are not equal to each other. One of them is a positive value, meaning it's going to have a fraction. The other one is zero. Okay, so they are not equal. This is not a true statement. I'm going to go ahead and cross this off. In fact, I'm just going to use my black. Cross that off. It's not true. Okay. Slope AC is equal to the slope of BD. BD. So I'm going to go ahead and highlight BD in blue. So here's where B is, and then it's extending all the way up to D. Are those the same slope? Are those equal? Yeah, they are. They're both going in the exact same direction. They're both positive. And guys, they're on the same line. Remember that we said slope is the same between any 2 points on a line. So it doesn't matter if I'm doing A to D, A to B, A to C, B to C, B to D. They're all on that exact same line. That means the slope is exactly the same. They're all equal. So yes, this is a correct answer. They're saying that the slope of AC is equal to the slope of the entire line. Is that true? Is AC the same for the entire line? The slope, not the size of AC. We're not talking about the distance between A and C. We're talking about the slope of AC. So what did I just say about slope of a line? It's the same no matter what, right? The same no matter what 2 points. So the same is going to be for AC as it is for the entire line. That is a true statement. Okay, now they're saying the slope of the line is equal to line segment AE over line segment EC. So here's line segment AE. I'm going to go ahead and put that in purple. A to E, and then E to C over E to C. How do we define slope again? It's what over what? Rise over run, right? So they're saying that AE needs to be a rise and that EC needs to be the run, and they must be connected to each other, right? That rise and that run must be connected. So is AE a rise? Yeah, that's a rise. Is EC a run? Yeah, that's a run. Are they connected to each other? Yep, they are connected to each other. So this is correct. This one says that the slope of line is equal to EC over FD. So here we just found where EC was. It's my orange. F to D, we found it before. It was at green. Well, we just stated that EC is a run. FD is also a run. So is that a slope? Run over run? No. Cannot be run over run. Okay? Those are two runs. They don't create a slope. This one says BF over FD. BF over FD. I'm going to go ahead and highlight this one in yellow. BF. BF starts here and ends here. Is BF a rise? Yeah. BF happens to be a rise. And then FD, we just found out FD was also a run. Are they connected? Are BF and FD connected? Yes. So then we have another statement that is true. So you should have identified B, C, D, and F as true statements for this. We're going to do another practice one like that tomorrow, so be prepared. Okay? Go ahead and turn it on over to the back. We're getting into our new section. We're starting section 5B, or unit 5B, which is focusing on circles. We're going to spend a lot of time on circles. In fact, our whole week is going to be spent on practicing area and circumference of circles, and then doing some in-depth detailed problems with circles, some real-life examples. How to go from a radius and diameter to a circumference and area, or the reverse, how to go from a circumference or an area and work backwards to being able to get diameter or the radius. So you need to have an understanding of the parts of the circle. So for here, the first word that we're going to talk about is radius. Go ahead and say that, radius. Okay, radius is the length from the center of your circle to any point on the outer rim of the circle. So you're always starting at the center of the circle, and then you are extending your way to the outer rim of the circle. It does not matter where I pick to go. I can go from my center to this point. I could go from my center to this point. I can go from my center straight down. I can go from my center straight to the right. It does not matter. The radius is the same no matter where you connect from the center to the rim of the circle. So this is the radius. Your diameter. Say diameter. Okay. Diameter is the longest length from one point on the circle, passing through the center of the circle and extending to the opposite point. It's the longest measurement inside of your circle, so it has to pass through the center. Again, I can start anywhere on the edge or the rim of my circle as long as I extend it and pass through the center and continue going straight in the opposite direction. That's called my diameter measurement. It is the longest measurement. Now, an easy way to remember which one is which, diameter is a longer word than radius. So diameter is your longer measurement, radius is your shorter measurement. Okay? It's also important to understand that the diameter can be found by taking the radius and multiplying it by 2. So if you know what your diameter is, you can take the radius and multiply it by 2. Or sorry, if you know what your radius is, you can take that, multiply it by 2, that will give you the measurement for the diameter. 2 radii are equivalent to 1 diameter. And then the reverse. If you know the diameter but you need to find the radius, you would just take your diameter and cut it in half. Half of your diameter is equivalent to 1 radii. And then you have circumference. Essentially, circumference is just the perimeter of a circle, but they call it the circumference. It is the distance around the rim of the circle. So it's this entire rim. Okay? That's going to represent your circumference. All right, so we have some other important formulas to make sure that we understand, not just that you would take twice the radius to equal diameter or take half the diameter to equal the radius. You also have the measurements for circumference and area. Okay, David, you need to be focusing on here and not on Ty's computer. And Ty, I hope you're not playing a game. Make sure you're doing your material for Miss Graham. All right, the formula for your circles. Your circumference formula. Circumference is found by taking the diameter and multiplying it by a value called pi. So pi, okay, that's what this symbol represents. This is called pi, P-I, is approximately 3.14. It's actually an irrational number. It goes on forever. It does not have any repetition to it. It has no patterns. It just goes on irrationally. But we estimate it as 3.14, or in fraction form, it's 22 over 7. So if you were to take 22 and divide it by 7, you would get approximately 3.14. Okay? Now, obviously, we're approaching Pi Day in about a month, which is March 14th. I do believe that we have school that day, so I'm hoping to have some fun activities for you guys if our calendar permits it. But some people do, like, there's a whole series of festivals and competitions surrounding Pi Day. Some things like people sit there and they memorize as many digits of pi as they can and enter into a competition. I think the longest, I can't remember how long, but I think they went into like thousands of decimal places for memorizing the digits of pi. Shamir? Shh. Guys. Shamir?
When are we going to learn part time or what time today?
Today. You're going to be doing the same thing. Today. All right.
How many digits of pi do you know?
Do I know? Not very many. Like, do I like pie, the actual food? Who wouldn't? I mean, pie is amazing. Please tell me you like pie as well. Kind of. Huh? You've never had pie?
I like pie.
Oh my gosh. What kind of deprived childhood have you had? Wow. I'm going to have to message your mother. Okay. Shh. Let's come back together. So talking about the different formulas for circles. Shh, quiet. Our first formula that we're going to focus on again is circumference. Circumference is found by taking the diameter of your circle and multiplying it by our estimated value of pi, 3.14. Usually when we use the fraction, it's because we're either A, dealing with a fractional value for our diameter, or B, our diameter happens to be a value that is divisible by 7. When we use 22 over 7 and we multiply it by a value that is divisible by 7, it has a easier chance of coming out to a whole number. So it just comes out to a nicer looking value. Other than that, we typically just use 3.14. So for all intents and purposes, I want you guys to use 3.14, unless otherwise stated. Shh. All right. So for example, if I'm wanting to find the circumference given 20 inches for my diameter, again, I know that this is the diameter because it's the measurement that extends across the entire inside of the shape of the circle, so I know that this is my diameter. Then what I'm going to wind up doing is just taking that diameter measurement, which was 20, and I'm going to plug it into my formula. Again, my formula is being circumference, which is found by multiplying your diameter times pi. Okay, and you're going to notice I'm going to color code a lot of these things because it just makes it easier when you're plugging it in for your formulas. So here, circumference is found by taking the diameter and multiplying it by pi. So all we're going to do is replace diameter with the value 20. This is a whole bunch of just substitution, guys. And we're going to take pi and we're going to multiply as 3.14. So we're doing 20 times 3.14. When we do 20 times 3.14, that's going to come out to 62.8. And that is in inches. Okay? Again, all you're doing is substituting into a formula. You're given the diameter, you multiply it by pi, that gives you circumference. That's it. Now, for area, if we locate right here, area uses the radius. It does not use the diameter. So just keep that in mind. Circumference uses diameter, area uses the radius. And not just the radius, but it uses radius squared. Radius squared, or radius times radius, if you need to remember it that way. Because I can't tell you how many people will always say, oh, 4 squared is 8, because they did 4 times 2 instead of 4 times 4. So if you need to, there's nothing wrong with saying, hey, I'm going to remember it as r times pi. Nothing wrong with doing that. Okay, so in a problem like this, can you stop? No, but you're not making it. You're not very good.
No, I made it the third time.
The third time, yeah.
That's for sure.
Sure. All right. So for here, again, they only gave you the diameter. The measurement that they gave you in this case was diameter. But I don't want to use the diameter. I want to use the radius. So who can remind us again, how do we change diameter into radius? Carden? Divide it by 2. So we're going to take the diameter, which was 20, and we're going to divide it by 2. So radius is going to equal 20 divided by 2, which is what? 10. So the radius is 10. Logan, do me a favor. Can you erase this wonderful drawing right here for me? Thank you, darling. Thank you. All right. So we have the radius now. We know what the radius's measurement is. It's 10. And we can go ahead and plug it into this formula. So area is equal to radius squared times pi. 10 squared times pi. What's 10 squared? What's 10 times 10? 100. Okay, so we get 100 times 3.14. 100 times 3.14. So the area for the circle is going to be 314. And that's inches squared, because we're talking about area. Area is going to be 314 inches squared. So again, you have to have an understanding of what value are they giving to you, and what value do you need in order to be able to find the circumference or the area. Go ahead and flip it on over to the next problem. All right. We'll do one more example together. If I have 9 yards for my measurement here, and I want to find the circumference, guys, I need you to stop. I want to find the circumference, so I need to do the diameter times the pi. What measurement is 9 yards in this case? Radius. This 9 yards is representing the radius, but I don't want the radius, I want the diameter. So how do I change radius into diameter, Logan? You multiply it by 2. Very good. So we're going to take the 9 and we're going to multiply it by 2, and that's going to come out to 18. So the diameter is 18. Now I can plug it into my problem. Circumference is going to be equal to the diameter, 18, times pi, which was 3.14. So we're going to do 18 times 3.14. That's going to give us 56.52. Okay, and that is yards for my circumference. Okay, now for the area, again, this was our radius. So we know that R is equal to 9. For my area, Area is found by taking the radius squared and multiplying it by pi. So that means for here, we're going to do 9 squared, and then we're going to multiply it by 3.14. What's 9 squared? 9 squared. Who said 18? Don't make that mistake. It's not 9 times 2. What's 9 squared, Richard? 81. You have to do 9 times 9. Don't make that mistake. Everyone always goes, I would never make that mistake, and then they make the mistake. Okay? So you're going to do 81 times 3.14. You're going to get 254.34. Shh. And that's yards squared. Okay, what I want you guys to do is you're going to do problems 1, 2, 3, and 4 on your own. You're going to identify what it is that we are trying to find. So here they're saying find the area of the circle. So what are we trying to find? You're going to put the formula for you're going to put what you're trying to find. You're trying to find area. What is the formula? What information do we need to know? So if it's area, we need to know what the radius is. Do we have that value? If they don't tell you that value, then how can you find it? What will it be? And then you're going to work it out. So you're answering each of these questions step by step, making sure that you understand what they're asking for. What information do you need? What's necessary? Okay, doing the 4 problems, all 4 problems. All right, here we go. Problem number 1. You were trying to find the area. The formula is radius squared times pi. So you needed to know what the radius is in order to be able to substitute it in. They don't give us the radius though. They gave us the diameter. The diameter was equal to 5. So what we had to do is we had to take the 5 and divide it by 2 to find out what the radius was, which was 2.5. Then we can substitute that into our formula. So instead of doing r squared times pi, we would do 2.5 squared times 3.14. 2.5 squared, otherwise known as 2.5 times 2.5, comes out to 6.25, and then you're multiplying it by 3.14. You'd get area is equal to 19.625 centimeters squared. Centimeters squared. Okay? For problem number 2, taking that same exact circle, now we want to find the circumference. So what we're trying to find is circumference, which means we're trying to do diameter times pi. Yes, they told us what the diameter was. Diameter was equal to 5. So then we just substitute it into the formula. Diameter times pi, or 5 times 3.14, you should have gotten 15.7, and that's centimeters, because it's just circumference or just perimeter. It's a single dimension. All right, go ahead and flip it on over to problem 3. For problem 3, given the circle with the radius measurement of 8 meters, we're trying to find the area, which is radius squared times pi. They did give us the information that we needed to know, which was the radius being 8. So we can just substitute that into our formula. R squared times pi comes out to 8 squared times 3.14. 8 squared is 64. Then multiply it by 3.14. You're going to get 200.96 meters squared. Okay, then taking the exact same circle, but this time we're trying to find the circumference, which means we need to do diameter times pi. They don't tell us the diameter, so we have to double that measurement to get to the diameter. Diameter is doubled. Okay, so you're doing 8 times 2, which is 16. The diameter is going to be 16, and then you just plug it into the formula. 16 times pi comes out to 50.24, and that is meters. Okay? All right, turn it on over to the last page. I'll put this back up there while you guys are working on your assignment, but if you have time, actually, you might not have time to work on it today in class. Quickly. All right, taking a look here. If the circumference is equal to diameter times pi, then you can actually work backwards. You can find the diameter by doing circumference divided by pi. You can do circumference divided by pi. So if you're given circumference, divide it by pi, and that will give you the diameter. Okay, so let's take a look here. if the circumference is 32.656, so we can take this measurement, circumference, and divide it by the value of pi, and that will give us our diameter. Diameter is going to be equal to 32.656 divided by 3.14. So if we do 32.656, and divide it by 3.14, that's going to come out to 10.4 for the diameter. And that's yards. That's your diameter. How do I find the radius from there? Jacqueline? Divide it by 2. If I wanted to find the radius, then I could just take that 10.4 and divide it by 2. And that would come out to 5.2 yards for the radius. Okay, go ahead and do number 2 and number 3 on your own, please. For problem number 2, Richard, problem number 2, 56.52 is the circumference. If we divide it by 3.14, we're going to get 18 inches for the diameter. If you take 18 and divide it by 2, you'll get 9 inches for the radius. So you should have gotten 18 and 9 for problem number 2. For number 3, take the circumference 77.244 and divide it by 3.14. You would get 24.6 miles for the diameter. Divide that by 2 and you would get 12.3 miles for the radius. Your assignment for tonight is on Delta Math. It's on Delta Math. You are going to, hold on, some of the questions are going to involve you writing it in terms of pi, which means you will not multiply or divide by 3.14. You will just leave it as 18 pi or 9 squared pi. So just be mindful of that. Others are having you round, so you need to make sure you know how to round properly.